All right, in this video, I'm going to go over a word problem that involves solving a quadratic equation. So let's read the word problem. A vacant lot is being converted into a community garden. The garden and the walkway around its perimeter have an area of 378 feet squared. Find the width of the walkway if the garden is 12 feet wide and 15 feet long. All right, and they gave us a little picture to go with it, just so we can picture it in our minds. And if you need to, read that again. The vacant lot is being converted into a community garden. The garden and the walkway around it, its perimeter, have an area of 378 feet squared. Okay, so the garden and the walkway, so our total area, AT, A sub T, is 378 feet squared. Okay. Find the width of the walkway. Width of the walkway. So W sub W, width of walkway, equals question mark. That's what we're looking for. If the garden is 12 feet wide, so width of the garden is 12 feet, and the width, or not the width, the length of the garden is 15 feet. I just put those little subletters in there so you know which width we're talking about, because there's a difference. That we got a width of the walkway and the width of the garden. The area of all of it. The garden and the walkway. Okay? And the picture lays it all out pretty nicely for us. So we have 12 feet wide garden and 15-foot long garden, and we have this walkway around its perimeter. Right? So it goes all the way around it. So, I mean, this is X, this is what we're looking for, but it's also there, and it's also there, and it's also there. That seems like it's important. All right, so we've written down everything we know. We kind of pictured it in our minds. Now, what else do we know? We know the formula for area, right? Area of a rectangle, because that's what this is. Length times width. Wow, that seems really easy for a quadratic equation. But because of all these measurements and being in their unique way and us only having certain lengths and the area, we're going to get a quadratic equation out of this, trust me. So what is the length of the total? Because we have the total area, right? So we need the total length and the total width. We don't have either of those. We just have the garden. We just have the garden. That's all we've got. So how do we know what the total length is and the total width is, Joe? Well, think about it. Think about length first, 15 feet. Okay. The total length would be up here, right? It would be 15 feet plus x, right? Oh, but it's not just one x. There's another x over there. So the total length is 15 feet plus x plus x. Does that make sense? We have the total area, it's 378 feet, if I write it down correctly. Feet squared. But we're just going to ignore the units for now. Wait until the end, and then we'll know the units. The length was what I just said, 15 plus x plus x. Another way to put that is 2x. 15 plus 2x. Or if you want to be fancy about it, you put the 2x first and add 15. And we put parentheses around it because we're substituting a number in for a variable. And when we do that, it's just my habit to put parentheses around things, and it's important. Very important. Now, same thing with the total width. It's 12 feet, right? But then we add 2x to it because we got to include the walkway. So 2x first plus 12. All right. That is getting close to a quadratic equation. It's kind of like it's already been factored, but it's supposed to be equal to 0. So we need to actually FOIL this out and move the 378 in so that we can solve this and set it equal to 0. Why is it important to set it equal to 0? Trust me, if you set it equal to 378, you're going to get the wrong answer. That's just how these quadratic equations work. So 2x times 2x, 2x times 12, 15, yeah. First, outside, inside, last numbers. FOIL method, right? So 2x times 2x, 4x squared. There's our x squared, so I'm looking quadratic. 2x times 12, 24x. 15 times 2x, 30x. 15 times 12, okay. I don't know that. Assume you don't have a calculator. 5 times 2 is 10. 2 times 1 is 2, plus 1 is 3. Long multiplication, we put a 0 in the next line, and we do 1 times 5. It's 5. 1 times 1 is 1, and then we add those together. Don't need another line. And we get 180 plus 180. Okay. Equals 378 still. Okay. Well, what do we do now? Subtract 378. Ooh, this problem could go on for a while. Subtract 378. Let's erase this. If you need it, you can always go back in the video and pause it and play that back over again, whatever you need. So 378 minus 180. The answer is going to be negative. We know that. 17 minus 8 is, why am I blinking here? Is it 9? Yeah. 2 minus 1 is 1. 198. Okay. 24 plus 30 is 54. X minus 198. Right? I think I'm right. Okay. Now, can we factor out a greatest common factor? Yeah. Does 4 go into 198? I don't know, but I know 2 does. So let's divide everything by 2. We get 2x squared plus 47. No, 47. 27. Losing my mind today. Minus 96 96? Yeah, 96. No, 94. No, yeah, 96. What am I doing? No, 99. Oh, okay. Yeah, so it's 18 times 9. Yeah. Equals 0. Now, why didn't I include that 2 that I factored out? Well, because when you factor out something that's a whole number, you could just divide by 2, divide both sides by 2, and then it's gone. So, now what? Now we have a quadratic equation. So, but I'm running out of room on this board. So I'm going to erase this. And rewrite this up here. 2x squared plus 27x minus 99 equals 0. Well, you take the easy way and just do quadratic formula. That works. But you'd be like squaring 27. We could do the grouping method. Yeah, what's 2 times 99? 198, right? Yeah, let's do that. In the grouping method, we do AC, right? So 2 times negative 99 is negative 198. And all the factors of that, and we need 2 of those factors that add to get 27. Well, 2 and 99 don't work. But 99 divided by 3 is 33. And since we divided that by 3, we need to multiply that 3 to the 2. So we get 6 times 33. That should give us 198, or negative. And look at it. Oh, if this is the negative, guess what? 33 minus 6 is 27. So I think we've got our 2 numbers there. So 2x squared minus 6x plus 33x minus 99 equals 0. Grouping, love grouping. So now in grouping, we treat each of these like they're their own binomial, and we do greatest common factor, right? So 2x, take 2x out, and we're left with x minus 3, right? Plus, and we got a greatest common factor here. 33 goes into 9 like we just did, right? 33 divided by 33 is 3. Both of those are the same, so we did it right. And the last step in grouping is we factor out the x minus 3, right? Because it's the same thing being multiplied by 2 different numbers being added together or subtracted. So we're just kind of factoring it out. And we're left with 2x minus 33 equals 0. And just like any quadratic equation, we set each of these equal to 0, right? So x minus 3 equals 0, and 2x minus 33 equals 0. Plus 3, x equals 3 feet. Okay. What is this number? What is this answer, though? That's crazy. Plus 33 divided by 2. So we're like taking 33 and dividing it by 2. We get x equals 33 halves, right? What? Somehow I doubt that's the answer. But how do we prove that? Well, we got to take this answer and plug it back into our original equation. if you can remember what it is, and see if it's right. We know 3 is probably going to be right. But let's see here. See if we can remember. Our total area, 378 feet squared, equals 2x plus 15 times 2x plus 12, right? That was our original equation. Let's plug 3 in there. 2 times 3 is 6 plus 15. 2 times 3 is 6 plus 12. 6 plus 15 is 21. 6 plus 12 is 18. 21 times 18. Ugh, a lot of math here. I'm just checking my answers. 8, 2 times 8 is 16. 1 times 1 times 2. 378. Boom! So, the answer is definitely 3 feet. Why did we get this other answer? It's a quadratic equation. It forms a parabola. There's, it's going to hit the x-axis at more than one point. But we have to know for sure that that's not the correct answer. And what is this anyway? It's in feet. It's 16 and a half feet. Why would the walkway be longer than the actual garden itself? Well, this is just a possibility. Like, what if the garden was really, really small, and what we were searching for was this walkway that was just this huge, rectangle of cement surrounding the tiny, tiny garden? That's what that answer is assuming. It's like, oh, what about this possibility? No, that's not what we want. And we know this because we can put 16 and a half into this equation here, and it'll be way off. Or maybe it'll be right on, I don't know. 2 times 33 halves. Plus, this other number might have come about because we foiled it out and we moved the 378 over there, and we kind of simplified it a little bit before we solved it. That's why there's this other answer. And 2 times 33 over 2 plus 12. Okay, well, the 2's cancel, don't they? So it's just 33 plus 15, which is 48. And the 2's cancel again, so 33 plus 12 is 45. What? Don't make no sense. So 48 times 45. Oof, I don't know what it is, but I don't think it's 378 feet squared. 8 times 5 is 40. 4 times 5 is 20, plus 4 is 24. 4 times 8, 32. 4 times 4, 16, plus 3, 19. 432. No, that's not an answer. Our answer is 3 feet. See, in quadratic equations, you can have 2 answers, but in word problems, there's only one, usually.